welcome back to the video tutorial series of the mobile computing and wireless communication. I am your instructor Varsha Ta. Let's start our lecture series. Today we are going to start the line of sight significant impairment. Okay, in last lecture we have learned about the propagation mode and what is the line of sight communications. Okay, now we will see the line of sight significant impairment. Okay, so first of all, just let's recover the propagations mode. So in last lecture we have seen the basically three types of propagations mode is there, which are the ground wave propagations, the skywave propagations, and line of sight propagations. Ground wave propagation, that is a less than 2 megahertz. Skywave propagations, the range between 2 to 30 megahertz, and line of sight propagation, that is a range more than 30 megahertz. So that is what line of the propagation mode. And here in this figure you can see the different types of propagations mode. So when the signals is going to travel through this propagations mode, what will happen? Where the signals will become the weaker. Okay, so that everything which type of obstacle is there, and what will be effect if there is an obstacle that present in between the way of the signal. So that effect that we will see in today's lecture. So let's see. Okay, so main our topic is what? Line of sight, the significant impairment. Okay, so reasons for the significant impairment of the line of sight. So first of all, when obstacle is present. Okay, so when obstacle is present, which are the impairment? So here you can see the one of the effect that is blocking or shadowing. Another effect can be reflections. Another effect may be refractions. Then it may be possible scattering of the signal, diffraction of the signals, and multipath propagations, and last effect is the noise. Okay, so these are the reasons when the obstacle is present. So this type of distortions can be possible in the signals. Now let's see when the obstacle is not present. So here you can see when no obstacle is present, so how signal is going to be weaker. Okay, so these are the three basic reasons. One is what? Attenuation and attenuation distortion, and another is what? Atmospheric attenuation, and last one is what? Free space loss. About this free space loss we have also discussed in last lecture, and today also we will see in this lecture. These are the three basic reasons when signals is traveling but there is no any obstacle, still the signals become weaker. Okay, so this effect we will see in this lecture. So let's start with the obstacle. Okay, so first of all, blocking and shadowing. Okay, so when the obstacle is present in way of the signal, what will happen? One of the effect is blocking or shadowing. So when this effect will happen, so an extreme form of the attenuation is a blocking or shadowing of radio signals due to the large obstacles. Okay, so the higher of the frequency of the signal, the more it behaves like a light. If the frequency is high of the signal, then it will behave like a light. So how the light is going to be transferred? You can see that is in a straight line directions. So if the frequency is high, it will follow the straight path, and if there is a obstacle in that path, so it may be happen the blocking or shading. So here in this figure you can see the effect of the blocking or shading. When the signals will reflected to that particular obstacle, it may be possible that obstacle will absorbs all the signals and it will not reflect that signal. So that is what blocking. Shadowing, that means what? A signal with less intensity will be reflected. So that is what? A shadowing. Now next effect is reflections. Okay, so reflection is what? If an object is large. compared to the wavelength of the signal. For example, huge building, mountains, or the surface of the earth, the signal is reflected. Okay, so if the size of the obstacle is large, then signal is going to be reflected. That you can see in the figure here. This is the building. Signal is traveling, and in its way there is one building. So through that building, signal is going to be reflected. Okay, so the reflected signal is not as strong as its original, as object can absorb the sum of the signal's power. Now next is refractions. We have seen about the blocking, shadowing, then reflection. Now we will see the refractions. Okay, so what is refractions? Refraction, this effect occurs because the velocity of the electromagnetic waves depends on the density of the medium, okay, through which it travels. So velocity of the signal depends on the density of the medium through which medium it is going to be traveling. Okay, so only in vacuum it is equal to C, but here no vacuum is possible in real. Okay, so as the figure shows, the waves that travel into the denser medium are bent towards the medium. So when signal is travel from lower density medium to the higher density medium, okay, so at that time your signal will bend to a specific angle. Okay, so that is known as the refraction. Now here, this is the reason for the line of sight radio waves being bent towards the earth. The density medium of the atmosphere is higher, closer to the ground. So that's why in line of sight communications, your signals will be bent towards the earth's surface. Now next is what? The effect that is a scattering and diffractions. Now both the effects are similar, but what is the difference? Scattering, that means what? If the size of the obstacle in the order of the wavelength is less, okay, then the waves can be scattered. And here, if the size of the obstacle is large, okay, so that at that time it can be diffractions. For example, the radio signals that is broadcasting in the in this area where the mountain is there. So diffraction is possible. Okay, and there is a very small obstacles in between the way of the signals traveling. So at that time it can have the effect of the scattering. Okay, so diffraction, this effect is very similar to scattering. As I told you, radio waves will be deflected at the edge and the propagations in the different directions. Now here you can see the multipath propagation effect. Okay, when your signal is traveling, when your signal is radiating from the antenna and now it is free in the atmosphere to reach at the destination, so it will follow the different path. Okay, so here you can see the different path. ABCD is there. A, that means free space loss. Okay, there is no any obstacle, but still because of the long distance it have the effect of the free space loss. B, that means the reflections. Then C defines the diffractions, and D defines the scattering. So these are the multi-path propagation effect. More than one effect is possible in a single communications. So that is known as a multi-path propagation effect. So what is multipath propagation effect? As I explained you, that is written over here. Radio waves emitted by the sender can either travel along the straight line, or they may be reflected at the large building, or scattered at the smaller obstacles. Okay, so this simplified figures that we have seen in the last slide and that we will see in the upcoming, both the figures are same. Okay, shows the three possible paths for the signals. In reality, many more paths is possible. Okay, so at the receiver, both the impulse interference, for example, they overlap in a time. Now consider that each impulse should represent a symbol. Each impulse, that means every time you are traveling, every time your signals is traveling through the different path, so that is known as one impulse, should represent a symbol, and that one or more several symbols could represent a bit. Okay, so one or more impulse define the bits. Okay, so here you can see that one or more impulse defines one bit, that is known as inter-symbol interference. So the energy intended for one symbol now spills over to adjacent symbols, an effect of which is called inter-symbol interference. To travel the one bit, it defines the different impulses. Okay, so it requires energy to travel this impulse, so that is known as the inter-symbol interference. And here you can see the three different paths that we have seen in last two slides. Side diffraction is there, line of sight communication is there, reflection is there. So in real life there are numbers of paths is possible, but here just it is showing the three paths. Okay, so this is known as what? Multi-path propagation. Now, last impairment is what? Noise. Noise, that means what? Any unwanted signal that is defined as a noise. Okay, so here basically different types of noise are there. We just discussed about four noise, and real there are different types of noises there. First of all, what is thermal noise? Thermal noise, it is the noise generated by the active and passive device because thermal agitation process of the electron. Okay, sometimes your mobiles become very hot. Okay, so that is what a thermal noise. Okay, because of that noise your mobile becomes very hot. Okay, then intermodulation noise. What is intermodulation noise? When there is some non-linearity in the transmitting system or the receiving system, intermodulation noise is produced. Okay, there is no any linearity is there. Non-linearity, that means transmitting and receiving, that is different, power is different like this way. So that is what intermodulation noise. Then crosstalk. It may be possible that you have faced this crosstalk whenever you are talking with the telephone line to your relatives or your friends. You may hear the voice of the another person. So that is what? The crosstalk. So crosstalk, that is what? Unwanted coupling between the signal path that is observed when the different users are talking on the telephone lines, and some users can listen to the conversations. So that is what? Crosstalk. Then next is what? Impulse noise. Impulse noise, that means it comprises the very short duration noise spikes. Some for a little bit duration, so volume will become very high, then it will down to the regular voice. So that is what? Impulse noise or irregular pulses having the high amplitudes. So that is known as impulse noise. Sometimes you may face this type of noise in your televisions, on your radio, and when you are playing that radio cassettes in that radio. So that is what? This impulse noise. Okay, so we have seen all the effects when the obstacle is present. Now we will see the effects when no obstacle is present. So basically three effects is that. So first is what? Attenuation and attenuation distortion. So when a signal is transmitted, its signal strength decreases as the distance increases. Okay, so this phenomenon is called the attenuation. What is? When the signal is transmitted, its signal strength is decreases. You just throw the ball. Is ball will travel with the same intensity to the as long distance? No. After some time, after traveling some distance, that intensity of that ball will be down. So your ball will travel with slow intensity. So that is what? Attenuation distortion. Atmospheric attenuation. Atmospheric effect is there because of rain, because of air, because of fog, because of snow, etc. So that is what? Atmospheric attenuation. Then last is what? Free space loss. Again, the free space loss propagation model is used for the measurement of the received signal strength when the transmitter and receiver of this communication system have the clear line of sight between the transmitter and receiver. Free space loss we just use to count how the transmitter and receiver are going to transmitting and receiving this signal. Okay, so this is what one of the propagation model that is used for the measurement. Okay, so summary of this lecture, we have learned about the reasons for the significant impairment of the line of sight communication when obstacle is not present and when obstacle is present. Okay, so we have seen the different effects. So this is all about this lecture. Remaining interesting topic we will cover in the next lecture. Thank you for watching. We will meet in the next lecture with a new topic. Thank you.